Okay, good afternoon everyone. Today is our physics topic continuation of yesterday's electric line of forces. Yesterday we have to study what is electric line of forces and what is electric intensity and what is uniform and non-uniform forces and representation method of electric field E equal to 1 by 4 pi epsilon 0 Q by R square. Okay, today we have to starting what are the properties of electric lines of forces. Okay, Michael Faraday introduced the line of forces. Michael Faraday is the scientist who discovered each and every electric field have different types of lines are here. The concept of line of force or visualizing electric field. The line of force is give the expand form of, otherwise give the imagine form of visualizing an electric field. Otherwise magnetic field also. The magnets also have a magnetic field lines, that field lines to show magnetic strength. In the similar way, electric line of force is an imaginary line. Actually this type of lines are not here, but we have to mention it because of easy to understand. Okay. The tangent at any point gives the direction of the electric field at that point. Maybe you have to consider any point. The tangent of that point is give the direction of electric field. That means I am considering a line here AB. This is my point P. The tangent of the point P, that means perpendicular line is called as a tangent. The tangent of that making angle with 90 degree. The tangent of the point is denoted by the direction of electric field. The electric field lines is discovered by Michael Faraday. It is an imaginary lines. It is not a true one. It is imaginary one. It is help to visualizing electric field and magnetic field, and any point to show its tangent, that is give the direction of electric field. So electric field ka direction is that point ka tangent direction. Next one, line of force are imaginary, but the field they represent is real. Line of forces are imaginary, but their representing field is real one. So electric field is real. Then representation method of the lines of forces, that is imaginary. The line represents, the electric field lines are represent field of system of charges. Okay. Then the field represents, the electric field represent, line represent electric field. That electric field represent magnitude and direction of electric intensity. You know what is electric intensity? E, capital E is called as electric intensity. What is electric intensity? 1 by 4 pi epsilon 0 Q naught divided by R square. Okay, so magnetic lines are represented by electric field, and electric field is represented by magnitude and direction of electric intensity. Okay. Next, properties of line of forces. So we have to compare this electrostatic field is represented by electric field lines. At the same time, magnetic field is also represented by the magnetic field lines. This chapter we have to dealing with electric field lines. First point, all the electric field lines are originate from positive terminal to negative terminal. All the magnetic field also starting from north to south. North means positive, south means negative. Second point, electrostatic field is a discontinuous curve. Discontinuous means it is cannot to continuous way. It will be discrete. In between it will be break, after that it will be continue like that. But in the case of magnetic field, it is a continuous curve. Okay. Then electric field does not return to the starting point. It cannot to return back. Then positive to negative, only this much. Don't come back to negative to positive because it is a discontinuous. But in the case of magnetic field, it will be starting from north and ending with south. Inside of the magnet, it will be moving from south to north. That means it is a continuous. Next point. Tangent of the field lines give the direction of electric field. I am already tell you any point, that point tangent to show the direction of electric field. That means the tangent of the field lines to give the direction of electric field. At the same time, magnetic field also tangent is the direction. Next one, field lines never intersect. It cannot to join together, never intersect. The magnetic field also, it is never intersect. Point number 4. We can draw line of force through every point of an electric field. The entire space and surface would be completely filled. with lines and no individual line could be distinguishable. We have to draw the diagrams of electric field lines. We don't get space in between the field lines, that much of occupied that is, and the space and surface would be completely filled. But in the case of magnetic field lines, there are equal distance in between the line of forces. But in the case of electric field lines, it is not compulsory equal distance in between them. It is very tightly packed, no space in between them. It will be fully filled. Okay. Point number 5. The line of forces originate or terminate at the surface at right angle to the surface. You can see here, it will be starting and ending with the right angle of that particular point. That is called as tangent is the direction. Okay. Point number 6. No field lines will passing through a container. Inside of a container, conductor. Inside of a conductor, electric field lines do not pass, because electric field inside in the conductor is 0. Conductor means it is allowed to flow of electrons. You already know that. So in the case of electric field lines, it do not allow to passing through the conductor. But in the case of magnetic field lines, inside of the conductor, magnetic field lines are increases. At the same time, outside of the conductor, magnetic field lines are decreases. Okay. Then next point.